There's a PC here, PCA and PCX. Okay, they are in two different networks. This is 10.10.10.0 10.1/24. This is 10.10.11.1/24. Okay. Routers fast Ethernet 0/0, fast Ethernet 0/1. This is 10.10 and this is 20.10 in case. Okay. Now, let's suppose this PC pings the IP address 10.10.20. Sorry, this is 11. Oh, wait. Just wait. Okay, 20.1, 20.10. So I'm pinging to 20.1. From where? 10.10.10.1. I'm pinging to 20.1. Okay. So as soon as I do this, an incomplete ICMP packet will be created. Where this will be the ICMP header. Then you will have the IP header. Then you will have the Ethernet header. The ICMP header. This is the total ICMP packet. Now, in the ICMP packet, it will have what type of, it will be a paying request. Okay, so IP header will have two on the source IP, destination IP. Source MAC, and then the destination MAC. As you know, same case, source IP is 10.1, destination IP address is 20.1. Okay, source MAC is known A, but destination MAC is unknown. Okay, same thing. Now, the PC will first check its ARP cache. Have I previously communicated with this PC 10.10.20.1? Do I know this device? Okay, so it will check its ARP cache. If the details is not found, then the next thing the PC will do is the binary AND. So doing the binary AND, it wants to understand whether they fall in the same network or not. Now, when you compare 10.10.10.1 and 10.10.20.1/24 is the subnet mask. So you have to compare the first 24 bits, correct? So it will check this 24 bits, it will check this 24 bits. Okay, so 24 bits will be compared. So if you see that, it is not same. Okay, so they don't fall in the same network. Next, what does the PC does is, when it is not in the same network, next the PC does is, do I have a default gateway? Do I have a default gateway configured in my IP configuration? If there is no default gateway, the ICMP packet will be straight away dropped because the PC is not allowed to communicate it outside the network. If there is no default gateway configured on the PC, the packet can never go out and the packet ICMP packet will be dropped and you will get a destination host unreachable or request timed out or whatever the messages. You will see how many types of ICMP messages are there, what are the different error messages and so on. Okay. Now consider I have configured the gateway 10.10.10.10, that is here, and 10.10.20.10. The router's fast Ethernet interface IP address will be your gateway, correct? Okay, so that is configured. So in case if the gateway is configured, then the ICMP packet will be valid. So yes, I do have a gateway. Who's my gateway? 10.10.10.10. Next, what is the question? Who is my gateway? Who is 10.10.10.10. Now what does it do? To check this, it will again check its ARP cache. Do I have a associated MAC address? For to reach the gateway also, I need the MAC address of the gateway. Correct? So it will check. Do I know who is 10.10.10? Check in the ARP cache. It checks in the ARP cache for 10.10's IP MAC address. If it is found good, if it is not there, then it will generate the ARP request. Now, ARP request is to find whom? The gateway now, not the destination PC. Okay, because I have to forward my communication to the gateway. So I will send the ARP request to 10.10. Who is 10.10? So the ARP request will be created. So the ARP request contains what? This is the Ethernet header. This is the ARP header. This is the ARP request. What will be the opcode? You have to unmute and speak.
1.
Opcode will be 1. Sender IP, sender MAC, target IP. Use the same terms for the assessor also. Target MAC, sender IP. Okay, sender IP is 10.1. Sender MAC is A. Unmute and speak. I cannot do lip reading there. Unmute yourselves. Unmute your mics. What is target IP?
10.10.20.1.
Kill him. Kill Arun there. We are looking for 20.1, Arun. I told you it cannot go outside. Correct?
Yes, ma'am. 10.10.
We are looking for the gateway. Don't do this mistake. We are not looking for this IP address anymore. I cannot reach this device directly. I'm all dependent on the default gateway now. Default gateway is 10.10. So I'm looking for 10.10 now. Okay, what is the target MAC address in ARP request? What will be the target MAC address?
Broadcast address.
Sorry?
Broadcast address.
Sure. I just said
Yeah, only.
no. I don't know the broadcast MAC destination MAC address. Correct. So what it will be here?
0000.
It will be all 12 zeros. Source MAC address will be A. Destination MAC address will be all FF. Yeah. Now it will be a broadcast. At Ethernet address header, it will be all broadcast. Done. Now the ARP request will go out looking for the default gateway. How many of our devices are connected in the LAN? Every device will receive the ARP broadcast. Only the router will reply back because that is 10.10. Now when the ARP reply the router is sending, I'm receiving the ARP reply. So the ARP reply, ARP request is a broadcast communication. ARP reply will be a unicast communication. So opcode will be
2.
Opcode will be 2. Sender IP will be
10.10.
10.10.
10.10.
10.10. Sender MAC will be Sender MAC will be what? Whose IP address it will be? Whose MAC address it will be?
Gateways.
10.10.
Yes, ma'am.
This interface MAC address will be. So it will be fast Ethernet 0/0's MAC address, whatever it is. Okay. Consider fast Ethernet 0/0's MAC address is P and F0/1's MAC address is Q. So it will be P. Okay. Target IP address will be
10.1.
10.1.
target MAC address
Yeah.
will be
Yeah.
A. Perfect. So this will be P and this will be A. Understood? So the reply will come. Now the PC has learned it will get the ARP reply from 10.10 and 10.10 is equal to P. So it will update its ARP cache. ARP cache will be updated. Then ICMP packet will be complete. Is completed and transferred. Now it will have P, that is fast Ethernet 0/0s MAC address. Understood? Now the ICMP packet now. This is not done. Listen here. Now ARP you are understood. Now the ARP request is done. ARP reply is done. I know my gateway. Now the ICMP packet will travel. Okay. So the ICMP packet, let's keep this color green. So now the ICMP packet is going. It has come to the switch now. Now what does the switch do? What does the switch do now? Switch has a MAC table, correct? In the MAC address table, it will have 0A:00. This is fast Ethernet 0/1. This is fast Ethernet 0/5 something. Okay. So on 0/1, I have PC A connected, and on 0/5, I have the router, that is R1 is connected. R1 with its fast Ethernet 0/0 is connected. Okay, that is P. Okay, wait, I'll not write it as R1, I'll write it as P. P0P:00, whatever, that is R1's fast Ethernet interface is connected. Now, when this ICMP packet comes to the switch can read only the source and destination MAC address. Correct? It can read only the Ethernet header. It is not bothered about the IP address. So it sees that the destination is P and P is associated with port number 0/5. So it will forward this packet outside 0/5. Now this packet will arrive at the router now. Okay. What will the router do? The router will first do what? It will check its routing table. Show IP route, correct? You will check the routing table of the router. So this is R1's routing table. So it has two connected networks, that is 10.10.10.0/24, and another connected network is 10.10.20.0/24. This is connected on fast Ethernet 0/0 and this is connected on fast Ethernet 0/1. Done. So when the packet comes to the router will see, do I know this destination? What is the destination network address? It is 10.10.20.0. So the destination IP address is 20.1, but it is not bothered about the entire IP address. It will only check what? It will only check the network address. Do I know this network? 10.10.20.1. Only network address will be compared with its entries in the routing table. So it sees that, okay, 20.1 is, yes, I know this network. It is connected to my fast Ethernet 0/1. Okay. Now when it sees that it is connected to its fast Ethernet 0/1, what it will do now? Now the MAC addresses that are there, this PC's MAC addresses cannot forward to the other domain. Okay. So it will remove the Ethernet header and add a new Ethernet header. Okay. So the previous Ethernet header that came from the LAN will be removed, or it will be edited, you can say, whatever it is. Okay. It will be removed and it will replace it with what? So source IP address will be, now the router has to give it to fast Ethernet 0/1. Now fast Ethernet 0/1, that is Q, will be the source MAC address, fast Ethernet 0/1, and destination MAC address, it doesn't know. It doesn't know where is this 20.1. It knows that it is on fast Ethernet 0/1, but it doesn't know where it is. So again, what it will do? it will do the ARP from here to here. So ARP will take place. ARP request, ARP reply. So it will learn X MAC address. So after learning X MAC address, this information will be filled here, and the source MAC address will be router's fast Ethernet 0/1. This gateway will be the source and X will be the destination to reach 20 network. Understood? Okay, and the ICMP packet will be sent towards, okay, it will come to the switch. The switch will have its own table here, MAC address table for this switch. This is switch 1. Okay, this is switch 2 if you consider switch 1 and switch 2. Switch 2's MAC address. Okay, so on 0/3 and 0/2 consider. So on port number 0/3, Q is connected. Sorry, first it will be the MAC address. So Q is connected, 0Q is connected to fast Ethernet 0/3. That is R1's F0/1 interface. Okay, and 0x:00, this is F0/2, that is for the PC. So when it comes, it will see that, okay, X is unconnected on 0/2, so it will forward it outside 0/2. Okay, now the ICMP packet reaches the destination. Now this is about the ICMP packet, the request or the echo request or the echo message, whatever you call it as. It is ICMP packet or echo packet or echo request. Okay, all these are the different names for ICMP packet. Now you speak about the ICMP reply. Now ARP takes place only when I'm sending the packet. Now the switches and the PCs are okay. They know their ARP tables and MAC address tables are filled now. So this time it will be only unicast. No ARP broadcast will take place. Now when the ICMP reply comes, then the source MAC address will be what? What will be the source MAC address? This time it will be a ARP reply. Okay, ping reply it will be. Okay, so source MAC address will be 20.1 and destination MAC address will be 10.1. This is source and this is destination now when the reply is coming back. So source MAC address will be PCX. Okay, and destination MAC address will be router's fast Ethernet 0/1, that is Q. Then when it comes to R1, R1 will again remove the Ethernet header and adds the header again. Now the source MAC address will be what? It will be P F0/0 and destination MAC address will be A from here to here. Understood? This is the packet flow. Again, it'll have one more stop at the switch. Okay, switch is there in between. Switch will check its MAC table. Okay, so destination is A. It is connected on 0/1, so I'll have to forward it on 0/1 port, and then it will go forward. Clear? Here on router also, there will be one more stop. So it sees that destination is 10.1 network. So do I have the entry? Yes, 10.10.10.1. So when it checks the destination network address, it is there on its fast Ethernet 0/0. So it gives it to fast Ethernet 0/0. Then fast Ethernet 0/0 will edit the header. Clear? Because it is an Ethernet interface, only a Ethernet interface can do this editing. Router doesn't do that. That interface is working on which protocol? It is working on Ethernet protocol. It is based on the Ethernet standards. It is a fast Ethernet connection. So this Ethernet header adding, removing can be done only by the Ethernet interface. Router doesn't do that. This interface is capable of doing that. Clear? Okay. So Ethernet header will be added. Okay. Or it will be edited. And then the packet, the ICMP reply. So when the ICMP reply comes, then you will see one reply or one successful exclamatory mark. Like this for 5 pings according to the router, and in the PC it is 5 ping request, correct? You see 5 replies. So 5 times they will send a request, ICMP request, and 5 times the ICMP reply will come, 5 or 4 times. Understood? Yes, any doubts with the packet flow? How it is? You should be able to explain this way only. Okay, we will do one assessment, maybe next Monday or coming Saturday or something. So we will talk about all the topics that we have covered so far. It'll be a one-on-one assessment with you guys. Okay. Probably next Monday I'll do. I'll give you 1 day or 2 days you'll have to prepare. So next Monday we will do the assessment. Okay. Okay. And we will see how you people are doing. And you will be marked in 3 colors: green, that is good; amber, that is you're okay; and red, that you're not good. Okay. Your concepts will be checked. Clear? Any doubts with this packet flow? Now there is one more method called as gratuitous ARP, where the ARP need not take place. ARP request need not take place if the devices are new and all supports gratuitous ARP or GR. Okay. What is the behavior is the routers and all, if it is supporting GR, they will keep, means as soon as they are on, their interface is on, they start broadcasting the GR message. Means they will tell that this is my IP address, this is my MAC address. So they will keep everybody informed periodically, like what is their details. So every device will be aware that who's my gateway. Understood? Okay. So the ARP catch will be always filled. So 90 to 95% devices are supporting GR. Only few old devices, if I'm using, they don't support GR. In that case, ERP request will take place. Okay. But you should understand in both the cases if GRP is supported or not, like what is the behavior you should understand. Okay. We will see that in the packet capture now. Let's suppose I have a router. Okay. Then I'm taking a Ethernet switch, 2 Ethernet switches. I'll do the same scenario and I'll put 2 PCs. Okay. And I'll do the connections. Motors fast Ethernet 0/0, to Ethernet 0, Ethernet 1, 2 PCs Ethernet, fast Ethernet 0/1 to Ethernet 0, Ethernet 1 to PC. Okay. I'm using the network 10.10.10.0/24. And this side I will use 10.10.20.0/24. Okay. The PC is 10.10.10.1. And the gateway will be, okay, so the gateway IP address is 10.10.10.10. And here the gateway is 10.10.10.20.10. I don't see the labels. Okay, so this is fast Ethernet 0/0. This is fast Ethernet 0/1. Okay, and its respective IP addresses. Okay, 10.1 and 20.1. Align over on the devices. Yes. Console the devices. Okay, so two PCs and R1. So PC1, I'll assign the IP address first. IP space 10.10.10.1/24 and gateway is 10.10.10.10. Checking for the duplicate address. Save. Okay, wait, let me do the packet captures here. So it is not fitting. It's gone. Now this is from switch to PC2. Okay, so I'm just enabling the IP address to it. PC2. I will say IP. Then I will say 10.10.20.1. See what happens now. /24 and then 10.10.20.10. And then so, okay. Now I'll go to the router. On the router, both the interfaces are still down. So we'll start configuring them. This is from R1. Can you see this? ARP gratuitous ARP is taking place 2020.1. As soon as it is up, okay, so the PC is supporting what? The gratuitous ARP. If you double click on this, so this is what type of request? It's a gratuitous ARP request. So Ethernet header source address is this. Okay, broadcast, it is doing a GR broadcast. Okay, destination MAC address is a broadcast at Ethernet. When you expand this, it's a hardware address. Hardware type is Ethernet. Protocol type is IPv4. Hardware address is 6. Protocol. Okay, wait. I'll remove this, guys. I'll delete this part. I'll delete it. Okay. Now, this is my Ethernet header. So in the Ethernet header, the source MAC address is the PC's MAC address. Destination MAC address is a broadcast all FFs, all 12 FFs. Destination, okay. So destination MAC address and source MAC address. If you go into detail, you've seen this already. Okay. So destination MAC address, you can see that your LNG bit is on and it is a multicast or broadcast MAC address. Okay. It's locally unique. Okay. The local unique MAC address. if it is 0, seventh bit, if it is 0, then it is global unique. Okay. And what is the address OUI? All FFs. Even the entire address is a broadcast address. When it comes to source MAC address, your LNG bit is also 0 and your individual group also is 0. So it is a unicast address, belongs to one device. Okay. Source address. And it is a global unique address. Okay. So that is about the Ethernet header. Now, what does the Ethernet address say? What type of, what is the next header? It is what type of data is inside the Ethernet header? It is ARP. Okay. There's no padding, frame check sequence. Okay. Address resolution protocol, ARP header. Okay. The ARP header, it's a gratuitous ARP. Hardware type is Ethernet. Protocol type is IPv4. So Ethernet uses 6 bytes, correct? What is 6 bytes? 6 bytes is equal to 48 bits, correct? Okay. This is 1 byte, 2, 3, 4, 5, 6. This is 4, 4, correct? 1 byte. So total 6 bytes, that is 48 bits. Your protocol size, protocol is IPv4, which is 4 bytes. 4 bytes is equal to 32 bits. This is your IPv4 address size. This is your MAC address size. Opcode is, it's a request. And it is gratuitous? Yes, it is true. It is gratuitous ARP. Then sender MAC is this. Sender IP address is 10.10.20.1. Target IP will be itself. Okay, it will have itself as a target IP. But at layer 2, at layer 3, this is layer 3 address. At layer 3, it is pointing to self. Whereas at layer 2, it is a broadcast. Clear? This is the gratuitous ARP. Any doubts with gratuitous ARP? No? Okay. Now, this guy is doing 20.1 is doing. Similarly, when the router interface you have configured the IP address, even the router will also start sending the gratuitous ARP. You can see that it is sent as soon as the interface goes up. Because I configured the interface, the PC1, then I started the capture, correct? So gratuitous ARP is already sent for that. So I couldn't capture it. That is why I told you that I started the capture and I showed you. So if the device supports, then it will send the gratuitous ARP. Now coming back to your this R12 switch one. Okay, let it be. Let's go to the GNS and let's configure the R1. So my interfaces are down. So I'll go with configuration terminal. Interface fast Ethernet 0/0. IP address 10.10.10.10 255.255.255.0 that is /24 and you will say no shut. See that as soon as the interface goes up, it is doing the ARP communications and gratuitous ARP comes into picture. Okay, R1's port ID fast Ethernet 0/1 is there. It does CDP protocol also. What is CDP? CDP is Cisco Discovery Protocol. Means the router will try to find if there is any other Cisco device connected to it. Now, the router, when it is sending the packet, it is sending it towards the switch, correct? Switch is also a Cisco device. So router and switch will exchange CDP between each other. Okay. That is Cisco Discovery Protocol to discover other Cisco devices. CDP, VTP, DTP, PAGP, UDLD. These are all the protocols that it is supporting. So currently it is running the CDP protocol. Now, coming back to the router. So one interface is up. Let's configure the other interface, fast Ethernet 0/1. IP address is 20.10 and I will say no shut. Do WR. R1 to 1 interface. This is doing switch 2. And this is okay. So this is also doing the ARP and the CDP now. Okay. The other device is also doing that. So can you see that earlier it was from the PC, now it is from the router side. Okay, 20.10 is also introducing itself. Now, when you go back to the PC, and check the PC, so ARP table is empty. Go to the PC2, so ARP, see that it expires in, it will be there only for few seconds. Okay, there is an expiry. I just got the update from 20.10, but it will expire in 59 seconds. It will go away. Then after this, if I want to communicate, again I'll have to do the ARP will take place. So after 52 seconds, let's wait if it goes away. Similarly, on the router, can I check ARP? Show ARP. See that? It has 10.10 and 20.10. Its own details. For fast Ethernet 0/0, can see that the router is maintaining its own details. Eleven seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, and it is gone. Okay. Now, let's suppose I want to ping the devices. I want to ping from the PC to the router. Now, the router did the GRP, but it is gone now. Okay. Now, in case if the router has sent the GRP again, you'll find the details. But it is not there. Now, I want to ping to 10.10.10.10, my router. Okay, I'm tapping into my router also, or you want to check that if it is going to the other network. Okay, let's put one more PC in the LAN and then ping to that device. Now the router, okay, I have one more PC. Will be 10.2. Okay, so I'll go to this PC and play this PC. Start console. I'll say IP 10.10.10.2/24 10.10.10. Okay, I don't need the gateway. I am not going outside the network. So this is for internal communication. So I don't need the gateway if I don't want to go out. Okay. So show IP. So gateway is not configured. Okay. Now this PC I'll ping to 10.10.10.1. Now I'll start the capture here also. Okay, and do this ping, enter. Can you see this? You have the ARP request and then the echo request. So in the ARP request, it is a broadcast. Request is broadcast. Who is 10.10.10.1? Tell it to 10.2. 10.2 is the one who's asking, correct? So when you open this ARP request, so your Ethernet header, source MAC address is this. The PC's MAC address, destination MAC address is the broadcast at Ethernet. Okay. Type is ARP. It's a ARP request. Operational code is 1. Okay. And even in ARP, it is showing it as a broadcast. But when you do it in packet tracer, when you open the ARP request, it shows in a different way. Hold on. This is my packet tracer. Why is my PC's interface off? Why it is down? Okay, it's connected to a wrong port. Hold on. Okay, I'll put one more PC. Ten dot zero dot zero dot two. Okay, so I will use the simulation here. Edit filters, show all or none, ARP and ICMP only two. Okay, so let this go up. I'll go to this PC command prompt, ping to 10.0.0.1. It's taking so long to go green. Usually it should not take so much time. So I disconnected and connected again. Oh, it's in the simulation, that is why it's not going green. You have to wait it for it to go green, then you put it to the simulation, otherwise it will not. Because at simulation level, everything is like halted, no communication, no process will take place. Okay, so if sometimes if you have gone to the simulation, then you have done the connection, make sure that you come back to real time so that it goes green. Okay, now I'll go back to the simulation. I'm going to this PC and I'm trying to ping to 10.1. Okay, now if you consider this, it's a ARP request. First is an ICMP packet. When you double click, you will see the outbound. See the source IP, destination IP. From 10.2, I'm trying to ping to 10.1. Your ICMP code. I will speak about this codes later. Okay. So this is source and destination IP address. And okay, now let's go to the ARP header. So Ethernet header, it's all broadcast. Okay. This is the ARP header. Okay, you can see that the target MAC address is 0. But in GNS, the target MAC address of ARP is also, where is it? Yeah, can you see that? Even this is also broadcast in the ARP header. So the behavior is different when it comes to the packet tracer capture and when it comes to your GNS capture. Let's suppose, let's go to the real PC. We'll start Wireshark. Let's capture a live packet and see whether it will be zeros or it will be ones or it will be FFs. Okay. I've captured some ARP here or here. Shall I open this? No, this is from R1. No, I don't want this. I will ping what is my IP address. Wireless LAN Wi-Fi 192.168.0.103. Okay. Where is my Wireshark? I don't want to see UDP, so apply not selected. TCP also, slice filter and not selected. So you can see a few ARPs here, whose 10.0.0.3. Let's expand. There's the ARP request. What type of request is this? Intel 89. TP link. Okay, this is the my access point. TP link. So that is sending a communication. Who has 103? It is asking me who has 103. Okay, let's try pinging some IP address. Where is my command prompt? I'll ping to. Okay, what is my auto config? It will give you much more in detail if you go with / all. You'll get the DNS, DHCP, all the details. Okay. ARP -A. So does it has the IP address of my gateway? Who's my DNS server? Okay. 49 dot something. 192.168.0.1 is that. Okay, let's ping to 168.0.2. 192.168.0.2. Not required that it should be there. Okay, I'm getting the reply. There is some device 10.02. So did any ARP came? 102. 14.2. No. 0.1 it is there. Why it is closing? Okay, so many command prompts are here. I closed GMS by mistake. Into I close this. The menu that I opened. 0.3. Let's see. I'm getting a reply. See that? Now ARP. Okay, let me stop this. I was looking for 10.3. So it's a broadcast. Means .3 doesn't exist, but I have done see. The target MAC address is zeros. Okay. Only GNS you will see it as broadcast. But in real time, in a real packet, this is zeros only target MAC address. So sender IP protocol, hardware and protocol address. That is your MAC address and IP address. Sender MAC, sender IP, target MAC and target IP. Okay, target MAC address is zeros because you don't know what is the MAC address. Clear? Yes. Okay, but in case if the assessor asks you, you will tell them both. Okay, sometimes it is all FFs or sometimes it is zeros. Okay, the target MAC address. So we were analyzing, my scenario is gone here, but we have done the captures, no? Let's open a project. Saved. Okay. Because I close the scenario, it will go away. You have to console again for them. So I did the ARP captures. Okay, so that is, okay, even that is gone. Because DNS closed in my packet captures are closed. Okay. Now, as I was trying to ping from 10.1 and 10.2, we did the ping from PC1 to PC2. I ping to 10.0. Okay, let me check show ARP if there's any entries. One is there for 10.10, that is the router. Okay, so ping 10.10.10.2. So the reply is working. So let's go to the packet captures. So ARP happened. Okay, and it is a, just wanted to show you the difference in the real packet. The ARP header also, the target MAC address is all FFs in case of your GNS, but in real time it will be zeros. Okay, so this is your ARP header. Protocol, hardware type, protocol type, hardware address is Ethernet address, protocol address is IPv4. Size of these two is 6 bytes, that is 48 bits, and 32 bits, 4 bytes. Opcode is a request. Sender MAC address, sender IP, and target MAC address and target IP address. When it comes to ARP reply, so this is the ARP response, which is a unicast, it's not a broadcast. So source MAC and destination MAC will be the other PC's MAC address and my PC's MAC address. ARP communication, it's a ARP reply now. So opcode will be 2. Okay. Ethernet and IPv4 address again. So now sender IP is 10.2, target IP is 10.1. Clear? Okay. So this is with the net within the network. Now let's suppose if I want to ping from PC1 to PC3. Okay, PC1 to PC2 probably. So PC1 is 10.1 and PC2 is 20.1. So when I want to ping from PC1 to PC2, that is 10.1 to 10.2, 20.1. See, the reply is coming. I'll be able to ping. Why? The router's routing table is linked to the network. So when I check the router's routing table, show IP route, the router knows both the networks. Both are connected networks, 10.0 and 20.0, which is connected on 0/0 and 0/1. When I in assessment yesterday, I asked many students, will these two pieces ping? They were blindly saying, comparing the first 24 bits, they say that they are in two different networks, they will not ping. They need routing has to be configured. Why do you need routing when there is only one router? Routing has to be done when you have another router, right? When you have to send it to next hop. That person is speaking about the entire static route command, IP route, destination network address, okay, and subnet mask, and he's selling the next hop IP. But where is the next hop here? There's no next hop only, no. Routing is needed only when you want to send the data to a network the router doesn't know. IP routing is a process of sending data from one network to another network. But if router is aware of both the networks, then you will do IP routing by default. Okay, default routing takes place because the router knows both the networks. In case if there is a network that router doesn't know, in that case you will do the static and dynamic routing configuration. Otherwise, static and dynamic routing configuration is not needed. Understood? My router knows both the networks. Do I need routing? Only what I need is, I need the PC with the default gateway. This PC doesn't have a gateway, it will not be able to ping. If you want, you can check. This is PC3. If I ping, see there, there's no gateway on this. Show IP. This guy, if I ping to 10.10.20.1, it will not ping because the gateway is not found. I will be able to communicate to another network only when there is a gateway. What is a gateway? It is a router that is forwarding the packet. Now, not required that the router is always forwarding the packet to some unknown network. It can forward from one subnet to another subnet. These are two subnets, correct? So within the network also, data transmission is possible. One router can be connected to multiple subnets like this, 10.10.30.0 also, 40.0 also. So all these are different subnets connected to the same router. So what this router can do subnetting, this is fast Ethernet 1/0, this is fast Ethernet 1/1. So all four interfaces are connected to this router and can do routing without any IP routing configuration. Why? Because the router's routing table knows that the connected networks are 10.10.10.0/24 that is connected to fast Ethernet 0/0, 10.10.20.0/24 connected to fast Ethernet 0/1, 10.10.30.0 connected to fast Ethernet 1/0, and 10.10.40.0/24 fast Ethernet 1/1. So all are connected networks. I don't need static or dynamic routing. No routing protocol, no static routing needed. Clear? Is the concept clear to you guys? Don't do the same mistakes like what other kids are doing. Okay. Concept clarification is very important. Even if you don't know the command, if you understand this concept, no, like what a router contains, whether it needs a IP route or not, don't blindly say that they are in two different networks, they will not communicate. No, tell the assessor that they are part of two different networks, but because router is connected to both the subnets, the router is aware of it. If the gateway is configured, they can ping. Yes? Concept knowledge is needed. Nobody will ask you what is the IP route command, what is the static route command, what is RIP configuration, what is OSPF configuration. They want to understand that you understand these things. Like what is inside the router, what is inside the switch, what will be the MAC table entries. The MAC table will have three MAC addresses. One is on port number Ethernet 1, it is connected to PC1. On Ethernet 2, it is connected to PC3. That is the MAC address. On Ethernet 0, it is connected to R1, fast Ethernet 0/0. So like this, you should know that this is the interface, this is the port, and this is the MAC address. So switch will maintain a MAC address table, or it will call it as a CAM table, content addressable memory table. So this knowledge is important. Concepts are important, not the commands. Yes? Okay. Now, as I was trying to ping to the other network from this PC, because this PC didn't had the gateway, I will not be able to communicate. You can see that simple, it is rejecting. MTU is 1500 by default. Okay. Now, the other PC, this PC did the ping, correct? From 20.1, I got the reply. Let's look at the packet captures. I will go to this from PC1 to switch 1. Where is the capture? Switch 1 to PC3. R1 to switch 1. Okay, we can see this also. R1 to switch 1. I'll just scroll this up. We did the ping here, correct? So can you see there? It is asking for who's 10.10. Did it ask for 10.20.1? When I did a ping, it did not ask for 20.1, correct? It is asking for the gateway IP address. So it is looking for the gateway, got the reply. Then you can see there it is forwarding the packet to 10.1 to 20.1. Now the echo request. See, the Ethernet address is source MAC address, destination MAC address. Whose MAC address is this? C0014F840000. Whose MAC address is this?
Gateway's MAC address.
Yes. So where is my router? My router, when I say show IP interface, You show IP interface fast Ethernet 0/0. No given. Not IP. Show interface fast Ethernet 0/0. Now it will show the MAC address. See? I'll open this capture. Can you see the MAC address? C001 4F84 and 4 zeros. So this is router's fast Ethernet 0/0 is the destination MAC address. But source IP address is 10.1, destination IP address is 20.20. This is my ICMP packet. Okay. Then it will have other details, all your Ethernet, your IP header, everything will be there. See there. So this is your ICMP message. So in your ICMP message, you will have the request. We will speak about different ICMP codes and all type and code we will discuss. Then you will understand what is this. Okay. Yeah. So, okay. So here sources, source IP address is PC1. Okay. And destination IP address is PC2, that is 20.1. But source MAC address is PC1's MAC address, but destination MAC address is router 1's fast Ethernet 0/0. When the ICMP reply is coming for this from 20.1 to 10.1, if you open this, now the source MAC address is C014F840000. It is going from 20.1 to 10.1. So this capture is between here, correct? From this router to this router. It is between here. Wait, I was looking at which capture? This capture. Okay, I want to see this capture now between R1 and switch 2. Because here it would have been edited, correct? When the ICMP packet comes here, okay, so the source IP address will be, source IP and destination IP will be, and source MAC and destination MAC. So when the ICMP packet is here, this packet, okay, so source IP address will be 20.1, destination IP address is 10.1. Source MAC address will be PC2 MAC address, and destination MAC address will be fast Ethernet 0/1. But when I see this capture here, okay, the same ICMP packet, source MAC address will be fast Ethernet 0/0's MAC address, and destination MAC address will be PC1. Okay, and it will be 20.1 and 10.1 only. So if I check what is the MAC address here, it will be same like the request. Okay, but I want to see this capture now. I want to see that it is fast Ethernet 0/1's MAC address. So to check this capture, it is from R1 to switch to, yeah, this one. When I scroll up, so ICMP request, see here from 10.1 to 20.1, you will see that it is not 0000, it is 01. That is fast Ethernet 0/1's MAC address. Go back to the router. Show interface. Fast Ethernet 0/1. Can you see the MAC address? It is C001 4F840001. So this is the source and destination is PC2's MAC address. Okay. So IP all. Okay, it shows the MAC address. Can you see the MAC address of the device? 005079666801. Clear? So from fast Ethernet, it is fast Ethernet 0/1, it is going to PC1. So the MAC address is changed at every point. Every Ethernet interface will change the MAC address. So MAC address will never travel outside the domain. Whatever the MAC addresses that are here within the domain, it will be local only to the domain. That is why it is called as layer 2 address. Layer 2 addresses, that is your MAC address, will never cross the broadcast domain. Understood? This domain's MAC address information will not travel to the other domain's MAC address. But the router will be aware of each other's MAC address. That's it. Clear? Okay, so before the packet is given to this interface, the MAC addresses are edited. Clear? Yeah? So who's doing this editing? Your Ethernet interface only. Fast Ethernet, Gigabit Ethernet, Ethernet, whatever the Ethernet interface that you have. So that interface will do the changes. Okay? And if router is connected to two subnets, it does not need any kind of static or dynamic routing because both networks are known to the router. So if default gateway is configured, just the default gateway is sufficient. If default gateway is configured on these pieces, it will be able to ping with each other without any IP routing configuration because default routing takes place. Why? Because the router is aware of both the networks. Clear? Any doubts with this? How the packet flows? Okay, you cannot see the MAC address table in the GNS because captures happens there only. MAC address table can be seen in the packet tracer. Okay, so when you go to this switch, when you say enable show MAC address table, see there on fast Ethernet 0/1. Okay, this PC's MAC address is there. 0/1 is this PC and 0/3 is this PC. Okay. Clear? And it was dynamically learned. Both are on VLAN 1. This is your MAC table. And this also refreshes. After some time, it is gone. Even MAC table also has two entries, static and dynamic. Static will be there permanently. Dynamic will go away. Clear? Yes. So what you will do? You will create the GNS scenario like this and you do the captures and then see again. See what you're understanding. Okay. See separate captures at every point. See that if you don't do it here also I'm fine, but do the captures in these two. Skip these at the PC level. Do the captures here. You should see that it is changing the MAC addresses when you're pinging from one network to another network. Okay, and do the analysis and then send the report to me. Clear? Okay. What are you seeing in the Ethernet header? If you see the Ethernet header, what does it mean? When you see the capture like this, okay, at Ethernet header, whose MAC address is this? Okay, whose MAC address is this? To whom does it belong? Okay, from where to where I'm pinging? All that. Ethernet header, IP header, and the ARP header and ICMP header both. Clear? Yeah? Okay, do one thing. Take your lunch break now. After you come back, you do this. Okay? Packet flow, we are done. Then what else is pending? OSPF will start. If you finish this soon, then we will do OSPF theory today. Okay? Yeah? You have done finding the details about OSPF? How many of you have submitted? I'll check my mail. From Larosh, Sona Santosh, Arun Kumar, Meghna, Abhisha, Prapta, Ruhi. Okay, so all these I've received. I've not checked, but I'll check. Okay. Okay, please take your lunch break now.